Video we're going to talk briefly about ratios. Ratios are really a way to compare two numbers that have a relationship. So I'm going to just jump to a really common ratio that you see all the time. 65 mph. We know this is 65 miles per hour. This should be correctly written as a ratio. This would be 65 miles per every 1 hour. Or 65 miles to 1 hour, 65 miles for 1 hour. What it means, we know, is that we can drive 65 miles every hour. It's a rate of speed. And if our speedometer in our car registers at 65, then we're going 65 miles every hour that we drive. So we could reasonably say that if we drive for 2 hours, we drive twice as many miles. So we'd go 130 miles in 2 hours. And you begin to see how ratios can be useful. They're useful in problem solving when we get into a proportion, which comes later. But we're just talking about ratios right now as a way to compare two numbers, because we're going to use a really useful ratio really soon called the slope for graphing lines. We'll get to that later. So just continuing with this ratio, 65 miles per hour, 65 miles. We could also write 65 miles. The same ratio would be 65 miles in 60 minutes, because we know there are 60 minutes in every hour. So if I wanted to work with minutes instead of miles, I would convert that. Now, a lot of times in the sciences you do stuff like this. You do conversions like these where you have to convert from minutes to hours, miles to feet, feet to inches. Those are actually other ratios that we could look at. Like we know that there's 1 foot, or there are rather 12 inches in 1 foot. That's a ratio. 1 foot to 12 inches. That's one way to write a ratio, is with those semicolons. That's a ratio. It's a relationship. Something those numbers have in common I can relate as a ratio. Hopefully you're beginning to get the idea. Other common ratios we would know are how many feet are there in a yard. So there is, in 1 yard we have is equal to 3 feet, and we see these as an equivalence, but they're also ratios. They're a relationship. So I could rewrite this as 1 yard is equal to 3 feet, something like that. Anyway, you get the idea. Ways to compare numbers that have something in common. That's what you need to walk away from. Now, in problem solving ratios, these comparisons can be written in 3 different ways. Let's take a comparison. Let's say we're talking about Skittles in a bag. And I know that on average there are 4 red Skittles for every 5 blue Skittles. I think there are blue Skittles. I don't eat them much. Anyway, you get the idea. So there's 4 red. If I drew out 9 Skittles, or if I drew out a number of Skittles, there would be 4 red, 5 blue would kind of be the common ratio. So I can write this in 3 different ways. I can write 4 to 5 with the colon. 4 to 5 is one way to write a ratio. It can also be written as just using the word 2, 4 to 5. The most common way a ratio is written is in fraction form, and that's the way you need to write it if you're going to work with it to solve a problem. So you'll do some practice with putting ratios in different forms. The whole point is just so you see, as you're problem solving, you understand how to read these situations. In a real problem, it's more likely to just say it. For every 4 red Skittles, there are 5 blue Skittles. For every 3 boys in Mr. Turner's class, there are about 4 girls. So the ratio is 3 to 4, so on and so forth.